Hi everyone! In this video, we are about to show you the final result of the SWART project, which has been funded by the European Union under the FP7 Marie Curie program. The objective of this project was that of designing, analyzing, and finally assembling an energy harvesting sensor node having the capability of scavenging solar as well as radio energy. Here we show you the schematic of what we did at the end. We have an energy storage unit, which is a supercapacitor. We have two energy harvesting modules, specifically one is to harvest solar power and the second one is to harvest energy from radio waves. Then we have a power management module, which has the delicate task of orchestrating how much of the harvested energy is fed to the sensor node and how much of that is retained and stored in the battery, which would be the supercapacitor. This module puts together the two energy harvesting channels. It provides the sensor node with the energy that it needs in order to operate properly, and it also manages the energy that is drained from the energy storage unit or that is sent to the energy storage whenever we have some extra energy inflow that we want to accumulate for later use. In this picture, you can see the prototype that has been assembled as the final result of the project. In the left-hand side of the picture we have the solar cells that have been used to harvest energy from ambient light. In the center we have the RF energy harvester that is used to scavenge energy from electromagnetic waves. And then we have the supercapacitors, which are in the right-hand side of the picture. A plastic encasing contains the node hardware, which includes the microprocessor, the sensing equipment and the radio. This node architecture has been characterized in the project, giving emphasis to the performance and to the energy consumption figures of radio and microprocessor. Now we show a quick video to demonstrate the energy harvesting capabilities of the node. Now we see the node has been covered so that no light can access that and no light is harvested. Now we remove the cover and then we perform a new reading. Here we have the tool that has been developed to manage the sensor node and to perform the measurements and to measure the statistics of the energy that we harvest. Now we have a first reading where the node is just harvesting ambient energy, ambient light inside the building. We're going to visualize now what is the value for that. Here at the end of the graph you see the peak, the small peak that corresponds to the instant where we have removed the cover. Now we're going to take a lamp and turn that on in order to see the impact of turning on the lamp on the harvested energy from the node. We perform a new reading, and then after that we see that the new value has increased as expected, as it should be, because then we have a higher radiation. And then we go and to the chart to see the behavior, and then we see a new higher peak which corresponds to the turning on of the lamp. In this last video we show the energy harvesting capabilities of the RF module. We have a Wi-Fi access point turned on and placed close to the node. We perform a first reading and we got the first result. See channel number 2 here in the video in the screen. Then we unplug we turn up the wireless router and we perform a new measurement. We cover the node also to for what concerns the channel number 1 power from the solar. Now we perform a new reading in order to see how the RF energy and also the ambient energy, the energy harvesting from solar, change. They both change, and in particular the RF harvesting will be diminished by an order of magnitude.